In this section, we will discuss the operator feedback on the optical monitoring systems. First, I would like to point out the importance of the communication between the operator and the service provider, especially when reservoir monitoring is involved. Because reservoir monitoring is a continuous process for the life of the well, and installing optical monitoring equipment is only the first step in this process. With that in mind, we have been in continuous communication with the operators on the performance of the optical monitoring systems. We have co-authored several SPE papers with the operators. We have participated in workshops, and sometimes we have presented jointly in conferences. Many times, the operators provided positive feedback on the performance of the optical monitoring systems. So the points that follow come directly from the operators. The optical monitoring systems provide real-time continuous monitoring and allocation in single-zone and multi-zone wells, and so they play an important role in optimizing production. In particular, the optical flow meters provide phase flow rates for individual wells, and those measurements can be used to determine the well performance by backtracking and comparing the results with the export measurements. Distributed temperature sensing measurements have been very valuable in detecting production anomalies such as leak detection, which has happened multiple times. So DTS is an important tool in well integrity management. Likewise, the pressure and temperature measurements are very important for drawdown management of the wells. On many occasions, the operators told us that having the multi-phase flow rate measurements from the optical flow meter allowed them to reduce the testing frequency for each well in test separator. So the frequency was decreased from once a month to once every 3 months. Now, imagine that a field may have 30 or 40 wells, and it is clear that the operator will save significant amount of time by the reduction of the well tests. That also accelerates the production. That is an indirect acceleration due to the reduction of deferment by approximately 5%. That number was provided to us by the operator. The monitoring systems provides permanent solution for the life of the well, and it's been reliable and robust in the 15+ years of service in the same field, and the measurements have been accurate and the system has been flexible. The optical monitoring system has been flexible because it can accommodate the expansion of the field. If the operator wants to add a new well to the field, what we need to do is to connect the optical equipment in that well to the topside instrument, and the expansion is complete from a monitoring perspective. I have a schematic here which demonstrates this process. Imagine that the field has well A, well B, well C, and so on, a number of wells. And the optical monitoring equipment in those wells, the optical flow meter, the PT gauge, and the DTS are connected to one topside instrument. And that instrument consists of a number of elements. The RMS, the reservoir monitoring system, this is the controller. we have an electro-optical module for the optical flow meters. There is a Bragg grating interrogator for the optical PT gauges, and there is a DTS box for the distributed temperature sensing measurements. So all the optical equipment from all wells in the field are connected to these respective boxes through optical switches. So if the operator wants to add a new well, let's call it well N, all we need to do is to connect the optical flow meter, the PT gauge, and the DTS to these respective boxes through the optical switches. So it's important that one topside instrument, which consists of these elements, drive all these optical equipment in all the wells in the same field. So adding a new well and new optical equipment does not require adding a new topside instrument. Everything is connected to one single topside instrument. And this is a huge advantage compared to other potential solutions which might require individual flow computers, individual systems. And for that reason, this also provides huge cost savings because there is only going to be one topside instrument. The optical monitoring system can adapt changing field and well conditions. And one excellent example is the well service change from producer to injector. And we will cover this in detail in a case history in chapter 3. But in a nutshell, for this change, there is no impact on the PT measurements because PT is insensitive to direction. And likewise, the DTS has no preference to the direction of the flow. It's a temperature measurement system, essentially. And the optical flow meter, as we have covered in chapter 1, is a bidirectional measurement device. So it can measure the flow in both directions without any loss in the accuracy. The accuracy is the same whether it's an injector or producer. It is possible that over time, the fluid composition in a given well may change. And when that happens, what we need to do is to enter the new fluid composition information into the flow computer, which is located topside. In terms of accuracy, no accuracy change is expected because this is an optical system. And for optical systems, the drift in measurement is minimum or insignificant. In addition, the optical flow meter has a permanent flow calibration. And for those reasons, we don't expect any accuracy change at any time for the life of the well. So I would like to finalize this chapter with a direct quote from an operator. This statement was made by the operator in a 2014 conference. And it says, in light of the reliable performance of the system, we are going to continue to use this system in our new developments. And through to their work, the operator continued to install new optical monitoring systems in their new field developments. And with that, we conclude chapter 2.